Okay. I hope you guys are doing well. Uh, እሺ መጀመሪያ እስቲ ስክሪን ሼር ላድርግ። Can you see? Yeah, can you see the screen? Wait, I'm just gonna fix something. Hello, guys. My name is Mubarak. I know some of you have seen me before. I was there in Addis, I think a couple of weeks back. 2 weeks ago, I was there at the office, and I know some of you are from other locations. I was at Abrahot Library, and I was there. I met with many of the developers, and today I'll be talking about this clean architecture. I'll be, we'll be going over this quickly, and we'll see a code example. And so let's get started with this. So the objective of this class is to understand what software architecture is and to look into types of architectures. We'll just be looking at this very briefly, and we'll be primarily focusing on clean architecture. We'll be focusing on why clean architecture is relevant and components that make up clean architecture. There is also a really important concept called dependency inversion, which is important aspect of clean architecture, and we'll be looking into that. And we'll end, the slides with quote of the day. And so, yeah, I think this is redundant. And let's go to this section. So, yeah, this is a slide with so many text. So what software architecture is in general, it's a high level structure or blueprint of a software system. And, it defines, how systems components are organized and how they interact with each other. And so when we talk about good software architecture, we are looking at the functionality, usability, reliability, supportability or portability, performance, self-reliance, scalability, flexibility, security, and maintenance of the software. So when we think about software architecture in general, we're talking about the long-term impact of our decisions, the decisions that we're making at initial phase before we start coding. And so it's really important concept. It's something that many of us struggle at the beginning, especially when you're at earlier phase of your software development cycle. You tend to focus on the small details, but not look at the bigger picture. But over time, as you work on many projects, you get to learn about you get to understand software architecture and the impact of many of the decisions that you've made in the past, how they ultimately impact your uh, performance of your software that you've designed. And so it's really important. So in general, when you talk about design and architecture, there is a confusion because you don't know when to draw a line between design and architecture. In many articles, like in many locations, you can see design used for a low-level system design, like a very low level, like design, like designing classes, interfaces, function, and responsibilities. And we have, design patterns, right? I'm sure like many of you are familiar with that. And when we're talking about design of component and module, but when you look at architecture usually is a bigger picture, really, and the skeleton and where and um, actually what and where. And usually we have like architecture patterns. For example, there's an architecture pattern called street hire, cloud, and so on. So there is trade-off both in architecture and design, and in architecture we are also looking at data storage choices and and sorry. And obviously both of them are done before coding, and so really, um, software architecture is used to refer to design of the entire system, and in general, software design is used to refer to design of the individual modules and components. If you have read Robert Martin's book, he says that the low-level details and the high-level details, the high-level structure are all part of the same whole. You can't have one without the other. Indeed, no clear dividing line separating them. There is simply a continuum of decisions from the highest to the lowest level. So what he's trying to imply is that we don't like really they're part of the same thing. One can't exist without the other, and really it's a continuum of decision from the highest to the lowest level. Even though we're using architecture to denote the high level uh, or the big picture of your software system, and so um, let's go to the so in general the goal of software architecture is basically to minimize the human resources required and required to build and maintain the system. So when we're designing an architecture, that's the major goal. Like we want to minimize, we want to make sure that our software in long run is maintainable um, and scalable and so on. If you give me like a program that works perfectly but is impossible to change, then it will not work when the requirements change, and I will not be able to make it work. Therefore, the program will become useless, right? But if you give me a program that does not work but is easy to change, then I can make it work and keep it working as requirements change. Therefore, the program will be the program will remain useful in long run. And so that's a key takeaway. And in general, when you have a poor software architecture, your productivity goes down as the code base increases. Initially, you might be able to, you might be highly productive. You can get a lot of things functioning quickly, but over time, you can have something like this. Your and your team's productivity can exponentially decline over time, and the cost of building your software can increase, as you can see in this graph. So I really want to discourage people from um, following this. We can clean it up later, and we just have to get to the market first. This is not a really good idea when you're working with your software system or when you're architecting your software. Yeah, because when the stakeholders change their mind in the future, you want to, like, let's say you build the software and when, let's say the stakeholder all of a sudden wanted to change some of the features, and you want to make that easy to make uh, that change in your software without impacting the structure of your existing software. Otherwise, it's going to be the work that you've done so far becomes useless. So Martin says slow and steady wins the race, and therefore, you know, you know, he says that good software systems begin with clean code. On the other hand, if the bricks aren't well made, the architecture of the building doesn't matter much. On the other hand, you can't make substantial make. You can make substantial make, with well-made bricks. And what he is saying is that software architecture is really important um, um, for long-term usability of your application. And this graph that you see shows you how your productivity changes over time. And you can see that if the software is poorly designed, if you're using a poor software architecture, you could see that it actually your productivity goes down over time. And with a code following clean architecture, you can have a much better productivity over a long period of time. And it's really software architecture is really important. It can decide whether it can determine whether you can win or lose in the market. Initially, you may have fancy product and you may put it out there. You have some of the basic functionalities working, but over time you want to compete with your competitors, and you want to be able to make the features of your application. You want to grow like features of your application over time. But if you have a really bad software architecture, it becomes very difficult. At some point, you may have to rewrite the entire code. And therefore, like, it's very important. Like, I just want to emphasize, like, um, uh, when we're starting our career in software, it's really crucial to understand, um, the architecture. At least, um, even if you are like initially like junior developers, uh, as a junior developer, initially you get to work on like the small details. You probably don't need to know about you probably don't need to worry about like the bigger picture or the architecture of the software. But some other people in your team who are more experienced, they come up with this software architecture, and you may have to work on like part of your software architecture. You may have to work on the use cases or the user stories of the software. And so you probably don't have to worry about it at the beginning, but over a long period of time, you will have to build the skills to be able to um, use best practices when you're architecting your software. So there are there are many types of software architecture, but some of them include like monolithic, layered, microservice, and domain centric. I'm sure like almost all of you are familiar with this monolithic because this is the architecture that we use, the MVC architecture that we use when we're working on our school project, when we're working on small scale software projects. That's what we use. And the microservices when you're working with distributed system. And we have many more software architectures, but we just want to mention these for as an here as an example. As a software developer, you must support the use cases and operation of the system, and you must also design a software that is scalable and maintainable. That's what Robert Martin meant by, the first concern of the architect is to make sure that the house is usable. It is not to ensure that the house is made of bricks. So in general, we want to basically, obviously, like your software has to meet the objectives. It has to solve the problems. Those are the bigger things that you are trying to address. And those aren't like, when you're coming up with your architecture of your software, usually you don't worry about these very small details of your house. For example, in this case, um, like bricks, for example, right? So you're looking at the bigger picture. So let's take a look at this clean architecture. Clean architecture is a software design philosophy that emphasizes separation of concerns and dependency inversion to create a maintainable, testable, adaptable system. We will be looking at a code example later on. Many of the things that we're discussing in this class, they become clear when we look at the example later on. And this concept can be used when building extensive application in any programming language, right? So this language agnostic and specifically useful when you're designing a complex application. If you're building an application for your school project, which you're supposed to finish it in a semester, it's probably not relevant to use this clean architecture because this is more useful. Um, Can you mute yourself? Okay, thank you. So, clean architecture uses layers to separate or isolate or decouple concerns. Similar concerns are separated out together, and the pieces don't really need to know about each other. Like we have layers. Um, I think this will become clearer when I show you the image, the diagram of this clean architecture later on. Um, and why we would like to use a clean architecture. So clean architecture, we want to separate concerns, dividing your code base into distinct layers, allow you to achieve loose coupling. Take a look at this diagram. We can see that, these are tightly coupled, like the part view of the diagram. And we want to avoid this kind of tight coupling in a software development. We want the components to be loosely coupled, like this one, so that we can be able to make changes. Like when we make changes to one of them, let's say if we want to throw away the second one, the changes that we have to do would be minimal. We just have to plug in a new component that is going to replace this one, the one that we throw out. And so, of every, and also we want to make sure like every component and their should be testable. And tight coupling means that closely, the components are closely connected, and changes in one module can affect the other. And loose coupling means that the modules are independent, and change in one module have minimal impact on the others. So other advantages of clean architecture, it improves code testability. When we talk about code testability, is making it easier for us to test the main functionalities of or the business logics of your software without worrying about the infrastructure. For example, when you're unit testing your code, you don't need to worry about the database. You can mock the database. With the clean architecture, it makes it really easy to do that. And ease of maintenance, obviously layers can be changed without affecting each other, and this reduces the risk of bugs and make the system easy to modify. It also makes your code flexible and adaptable and scalable. Um, incremental changes to your software will have minimal, incremental changes, like changes to one component that you have in your software. It's supposed to have minimal impact on the other component if you're following the clean architecture. And so this is the diagram showing components of clean architecture. Domain-centric architecture, the domain is in the center, and we're building layers on top of it. And outside layers can reference inside layers, but inside layers can't reference outside layers. As you can see in this diagram, we have this direction of dependency at the center, where we have the domain or the business. This is where we have entities. We also call this layer entities. Outside of that, we have the use cases, and we have the web UI, which is a presentation layer, And we also have infrastructure layer. They're not the same. These two are not the same. Infrastructure deals with other components of your software, including database and external plugins that you add to your software. And this is the direction of dependence in general. Uh, this will become clear when we look at the example, when we look at the code example. And so because this diagram is kind of difficult to understand, really, and this one makes it clear. I think it makes it way more clear. And you can see these arrows which showing the direction of dependence. The domain entity layer does not depend on any of the other layers, and the application or use case layer depends on the domain and entities. It also relies on abstractions or interfaces to interact with the infrastructure layer. As you can see, we also, like for example, the web or UI or the presentation layer depends on the use cases and also, the domain, transitively depend on domain. And so you will see how we can be able to achieve this loose coupling and avoid dependence of these layers on the outer layer. There should not be any dependence of these layers on the outer layers to use a clean architecture principle. Yeah, again, here we're explaining each part, like the domain layer or the core layer. It's a fundamental business object of the application. It includes the business logic and rules. It's independent of the outer layers, and the use case are specific business actions or application service that can be performed. Interact it interacts with the entities to achieve specific action goals, but it does not depend on the outer layers. It uses interfaces to interact with infrastructure layer. Infrastructure layer provides services to the use cases, and use cases rely on abstraction or interfaces to interact with this layer. And so the delivery layer, it could be a web interface, API, CLI, and so on, and sends out input to the use case and presents output back to the user. It interacts with the use cases. We don't want the application layers to be dependent on the infrastructure layer. As tools and frameworks can change over time, but the business rules usually remain the same. High-level modules should not depend on low-level details like the database or API, which are part of the infrastructure layer. Both should depend on the abstractions, as you can see in the diagram. So what we want to avoid is the high-level modules or class or functions to depend on the low-level modules. And that's what we want to avoid. And to be able to do that, we can easily achieve that using these abstractions or interfaces. And so, the abstractions, they don't depend on the details, and the details should not depend on abstractions. So the abstractions basically allow you to be able to change this infrastructure with a minimal impact to the use cases or the higher level modules. Use cases depend on abstraction interfaces to interact with infrastructure, and infrastructure layer provides detailed implementations of interfaces like high-level business logic isolated from details of how the operations are performed. So there is a very interesting concept called dependency inversion, and to achieve dependency inversion, we also use dependency injection. Dependency injection and dependency inversion are not the same. They're related concepts, but they are not the same thing. Dependency injection in general defines specific technique. It's a technique for implementing dependency inversion principle where dependencies are provided to a module at runtime instead of being hard coded or created by the module itself. And we have an example code that you can check when you have time. You can go to this repo. This is an example that many people use. You can take a look at how they structure the code base with clean architecture in mind. And you can check it at your own time. But we'll be looking at our own example. And let me show you the example. Let's see if you can see the screen. Can you see the screen?
No, not yet.
Okay. So let's see. Let me move this thing. We'll be looking at a code example. Like things don't become clear just with these slides. You have to actually look at the code to understand how it's used. And okay. So the example that I'm going to show you, it's a very basic example. As we discussed earlier, we don't use a clean architecture to design like simple applications or simple softwares. We use it to build like complex software. But just to show you as an example, like there is a simple program that I designed to show you or to demonstrate the concepts. So this is basically a software that manages a blogging platform where users can create, update, and delete and list blog posts. So first thing that I want to go over is the concept of dependency inversion. First let's go through the this folder structure. We have entities which are at the center of the diagram that we saw earlier, and we have the use cases which depend on entities, and we have here infrastructure and delivery layers. We also have interfaces. We use interfaces to basically guide the communication between this infrastructure and this cases layer. We use it to loosely decouple these two, basically. So let's take a look at these entities. Like entities are, for example, entities like they're very they have the business logic, right? So like an author, for example, supposed to have these details, and post supposed to have these details, and they don't depend on anything else. This is all about like the business logic, really. The business logic here means like the details specifically required for the business as part of the business, and so we have the use cases layer where it interacts with the entities and achieves certain objectives, which could be to create a post, to delete post, list post, update post. These are use cases. And to be able to achieve these, you interact with the entities, and also you use interface to interact with the infrastructure layer. I'll come to the interfaces part. And so you can see that this is it doesn't directly depend on the infrastructure, but instead it uses the interface, for example, to find post by ID here, right? There is an interface we have for post, and we also have an interface for author. And so basically, these abstractions they can be implemented in the infrastructure. Let's say you are initially using MongoDB database at the beginning, and at some point you decided to switch to SQL database. And to be able to do that, the only thing that you have to modify is implementation of these abstractions or these interface in the infrastructure layer. And I'm going to show you how. So let's say initially we had a MongoDB database, right? And we have this implementation. These concrete implementations are for MongoDB specifically, and like find by ID and all these things are MongoDB specific. And so um, when you switch over to, like, let's say PostgreSQL, all you have to do is basically, so you can see like it's implementing the interfaces, right? Here we're just implementing the interfaces, but with details specific to the infrastructure or the database here. So when you switch over to PostgreSQL, all you have to do is just um, uh, basically implement the same interface with a different details of the implementation of that interface. So when you are saving, it's different here for SQL database, but um, it will not have. So when you switch from like MongoDB to PostgreSQL, it will not have uh, almost like it will not have any impact on the use cases because the use cases depend on the interface, and the interface remains the same as you move from MongoDB to PostgreSQL. And so, and also there is something I want to go over, which is dependency injection, which we discussed earlier. Um, and so here you will see that so uh, different implementations of the interfaces are injected into the use cases, and you'll see because uh, initially we were using MongoDB and then we switched over to PostgreSQL. And so you can see in this code, we're using MongoDB at the beginning. Sorry. Uh, and so let's say if you want to switch to Postgres, you would use something like this to initialize. It's commented out. And so here's where the dependency injection comes in. So basically, here you're using details specific to the MongoDB. You're injecting this infrastructure, uh, the infrastructure object of the infrastructure layer into the use cases. And so it would not have like it would remain the same like if you were to use the Postgres, right? If you were to use the Postgres SQL, you just have to change this part, right? This is where and the use cases have no knowledge of this uh, interface, right? So they don't have any knowledge of what the infrastructure layer is, right? They know it in runtime, right? Because you're injecting it here, and it works normally if it is SQL or MongoDB, but they will be able to see that when you're executing your code, and so basically these allow you to achieve loose coupling or decoupling. Use cases are decoupled from specific database implementations, and they don't know whether they're using MongoDB or PostgreSQL. They simply rely on the abstraction, the uh, the abstraction or interfaces, and this makes your code flexible and testable. Um, and if you have any question, I can address your questions now. But before we do that, I want to go to the quote of the day. And there are some relevant resources that you can check later on, and I'll share those as well. Let's see. So yeah, these are relevant resources that let's see. These are relevant resources that you can use to learn more about this architecture. It requires a lot of practice. It's not gonna, uh, you know, uh, unless you do some programming, it will not be easier to uh, grasp the concepts that we've discussed. And also, take your time to check this Clean Architecture book by Robert Martin. And it's a really useful book. So what? Yeah, these things. So this is quote of the day. The only way to go fast is to go well. And that's what clean architecture allows us to do when we're building um, scalable applications. So yeah, the only way to go fast is to go well. And keep that in mind when you are architecting your software. So let me know if you guys have any questions. Is there anyone with a question? Okay, should the interface be written first before anything else, even before the dependency injection? I think so. Yeah. I mean, the interfaces would be important. Obviously, you need to know which architecture, I mean, which infrastructure that you're going to be using. But um, the interfaces, obviously, you need to write the interfaces before you implement the concrete details. Like, for example, the concrete details of like MongoDB, like save, like when you save, like, for example, when you save some content, you need to be able to first have the interface and then you go ahead and implement the concrete details of implementation specifically for MongoDB. Yeah, dependency injection comes after. Is there any other question? I have a question. Facing things like password validation, hashing, and also JWT, where should we place them? Um, so those are like, for example, those are implementation. So you will have entity, right, where you will be having those details, which are not dependent on the infrastructure, which will be here. And so this will be where we will have the objects to represent entities, including the details of each entity, which will be relevant. I mean, which will be relevant part of or relevant aspect of your business logic. And then, so you will have, like, for example, right here in the delivery layer, I forgot to talk about this layer, actually, the delivery layer, right? So this is where you actually implement the handlers, right? This is where, these are the functions that you call from here. And so, for example, like these are the HTTP routes, and this is where you actually implement these the web API. Actually, that's where you do that. And so yeah, and this is where you can do the validation.
You're not
Okay.
sharing your screen.
Oh, sorry. Okay, sorry guys. I thought I'm sharing my screen. Sorry. Uh, okay. So earlier I forgot to discuss about this layer, right? The delivery layer. And this is the outer layer. And so this is where we have the handlers. And like here in the main function, we have these routes. Obviously, this is not where you would put them if you're building a big application. This is just for demonstration purposes, just to demonstrate the concept. I place these routes in the main file. So you have these handlers, the web API, and you have these handlers, and this is where you do those validation, be it authentication or whatever that is that you're trying to do, and you could be able to do that in this layer, and you could implement the handlers here. Any question? I know, like there are guys in, who are in electricity and have used this clean architecture. Like, uh, like I know, like for example, so if you guys know about Akil, right? The Akil project, they use the clean architecture principles. Um, so I haven't gone through the code details myself, but I'm sure like there are people like, for example, Malik is the lead of Akil. I think she knows about um, uh, this detailed implementation. She actually led the detailed the implementation, the code. I mean, she's a team lead, so she has she knows, she has a practical experience. So you could probably speak with her to understand these concepts more. And I'm sure like she has a few things to share with us. Is there anything, Malik, you want to say? Is there anything that you like to? Yeah.
Okay, yeah, I think like whatever like you've presented, like that's the main and the core idea of like building projects that are scalable. So yeah, we follow the same thing in Akil. I can share the repo, and then we can also go through the way things are structured
Yeah,
in our yeah
yeah, that would be
repository.
good. That would be
Okay.
good. Yeah, let's do that.
Okay, let me share my screen, and we can go through like our code base and how things are implemented in Akil. So yeah, like the basic things, like whatever you mentioned, we follow them. So with Akil, we've also like go through different implementation of like this clean architecture, and we selected the one that we like want to go with. So the architecture we follow for Akil is something like this. So it's similar. The router doesn't like know the implementation detail of the repository or the database, and like the repository also works and integrates with the database, talks to the database, and we also have like the domain layer where we structure like the main basic like logic in our platform. So this is the repository of Akil. So like we went through like this approach because like it helps a lot in structuring our codes, and also like it helps in uh, testing every part of the code. For example, we can go through some of the like the implementation detail. For example, we have user repository, which talks like with the database and have the basic like implementation detail of the user. So we also have like user repository test, where we test where we write the like unit tests that are related to the user repository. So it makes your life easier. It helps you make your codes testable and things like that. And as you can see, like we are only mocking the database here. Uh, so we don't have to worry about like the router, for example, the HTTP and things like that. It only stops with the database, and the things like for the unit test that you wanted, you'll be only working the database here. So we also have, for example, the use case layer. So in these use case layers, the main like interfaces are implemented here, and like for this one, like they'll be talking with the repository. So like if we wanted to change, for example, the database implementation, or like the way we implemented, we would be like only changing the user repository implementation. So the repository implementation of that would be replaced. And for the use case, as far as like the use case is concerned, they only know the interfaces of the user repository, and then like this would be called on the use case part. So yeah, even on top of the clean architecture, for example, we were able to bootstrap some of the things. For example, we're using the Mongo database as a database, and like for things, if you wanted to change something related to Mongo, we have this file where we like where we created and added our own logic to accommodate like the real world like use cases that we face. So for example, on Mongo driver, the Go Mongo driver, it doesn't have the basic like implementation of like writing the created data and updated data, like populating those fields in the model. So we we were able to do that in our own Mongo Bootstrap like function, and then added that like at the end. So instead of going through every update and create function that we use in different part of the code, we added it here so that like once this function is being called by many of the repository implementation, it can be applied to all. So yeah, uh, even like there are some utility functions that we uh, have, and then it's like outside of the like the main uh, business logic, and then we'll be calling them in our different section. So like the other one is also like the delivery layer where we route everything. So like for us, for example, okay, mm, the way we so like if you for example we have public routers where we don't need authentication, and then the controller handles that. And then if you wanted to have something authentication layer before the controller and router, we can have these things as a middleware here. And then all the logics of like for example the things related to JWT and things like that will be handled in this middleware. So we have um, middleware section here. So all the JW authentication related functions are created here and handled here. So we also have other middlewares of our own, which, for example, we wanted to track some activities that the user does in our platform. So we would just intercept the request before it goes to like before talking to the controller here, and then log it in our database so that we know like when the request comes and then what they need in the backend. So it's really easy for you guys to add things and then create another layer and then talk with other services, other things. It helps you do that in easier way. So like everything is unrelated, and if you want to change, for example, the database, the only thing that you would be caring is about the repo, and you guys can like change database, change different like tools that you use. And then for example, if you wanted to add something which is like authentication authorization on top of this, we were only concerned in adding it here. So it helps you in scaling your project in easier manner if you are following such kind of best practices, like best architecture and clean architecture in your implementation. So this is how, for example, Akil backend is formed, and then it helped us a lot in accommodating a lots of use cases that we face in real world problems. So this is how it's been implemented, and it helped us a lot in extending the architecture to fit our specific use case. So
Yeah,
yeah.
yeah. Thank you so much. Thank you so much, Mahi. This is this makes a lot of things easy. I think they can. Yeah, maybe you guys can ask her questions. I don't know if you have any question to her, but this is a really good example, and I'm glad that we have this project example. And it looks like there are a lot of people in FSD who have practical experience, so you can ask questions and learn from their experience. And if you have a chance, take a look at the example that I also included in the slide, and you can learn more about it from there. Yeah, are we all good? So uh, and okay, so I mean, if you're using like even if you are using like other protocol, right? Um, uh, like so, the ideal folder structure is like just following the principle that they have, and really, I think practically when you try to implement, um, so when you actually implement, so like in the example we use this folder structure, right? So like if there is anything new that I mean, I think almost all of the things that you would like to add to your application can be included here. But if there are, yeah, ideally, like this is exactly like we're using, you know, the layers to differentiate between each one of them, um, and really, um, uh, you can basically the folder structure may depend on your project. For example, you can have other folders inside the library, right? If you look at this example that I shared with you, um, the example that I shared with you on clean code architecture, let me show that. Um, uh, as long as you're applying the concept, and as long as the architecture that you're following is clear from the folder structure, there isn't really you can have as many. Can you see the screen? I think let me yeah this one. This is the example I shared with you guys. You could also take a look at this example. This is also a really good example. Um, and for example, if you look at this folder structure, just by looking at this folder structure, we can tell that they're using these concepts of clean architecture from the naming like domain, infrastructure, web, application. This is where you expect to see the use cases, and this is where you expect to find the entities, and this is where you